This problem is to change the order of integration and to evaluate the double integral from 0 to a x square by a to 2a minus x xy dx dy. So we will quickly have a recap on the 4 points we need to do to change the order of integration and evaluate. First one is going to be the check the direction. So we'll have to check if the direction of integration is going to be the same as the limit. If not, then we'll have to change. The second one is going to be identifying the region, and then you'll have to sketch the region to identify it. So we'll have to sketch them. The third one is fix the new limits, and the last one, using the new limits, we will have to evaluate it. Now for the first one, checking the direction. We have the limit as x square by a and 2a minus x. We have to keep in mind x cannot be the limit of itself. So we know that like poles repel each other. So whenever we have a limit of x, that has to be for the variable y. So y varies from x square by a to y varies from 2a minus x. So this is the limit for the variable y. And next followed by it is the constant limit 0 to a. But now since y has to be integrated first, this must be dy then followed by dx and not in the given format as dx dy. So now we rewrite the problem. So the given problem is integral from 0 to a, integral y varying from x square by a to 2a minus x xy dy first and then dx. So now first step is over. We go for the second step, identifying the region by sketching it. So the limits are y equal to x square by a, y equal to 2a minus x is equal to 0 and x equal to a, the constant limit. Keep in mind to use two colors to distinguish between your axis and the region to be bounded so that you don't get any confusion when you're plotting it. So this is going to be our axis. Let me take the axis in black color and then plot the remaining lines in red color. So x equal to 0 is going to be your y-axis. So we'll have your y-axis. So this is going to be my first line. So I am naming it as x equal to 0. Now next, x equal to a. Let this be the point a. So we have this to be x equal to a. So this point is going to be the line x equal to a. So this point is 0, 0. This point is a, 0. Now we have drawn the two lines. Now coming to the third one, we have this to be equal to y equal to 2a minus x. So x plus y equal to 2a. How to plot this line? Give x as 0, y will be 2a. So 0, 2a is 1 point. Give y as 0, x will be 2a. So 2a, 0 is the other point. So the straight line x plus y equal to 2a passes through the point 0, 2a and 2a, 0. So now let us plot the point. So this is going to 0, 0. Now next is going to be a, 0. So equally distance. Let me plot the point 2a, 0. So similarly we will have here 0, a, and so the second portion over here, let this be 0, 2a. So the line passes through 0, 2a, 2a, 0. We will now fix the line which passes through this point. So the straight line which passes through 0, 2a and 2a, 0 is this, and the name of the line is x plus y equal to 2a. The last one is going to be the curve y square is equal to x square by y is equal to x square by a. So we have x square is equal to ay. Since this is square, this is not a straight line, this is a curve. This curve is called as a parabola. So this is a parabola open to the top. So it will look like this, something like a U, but I need to know where it crosses these lines over here. So the line which is lying over here is x equal to a. So x equal to a, at which point this parabola crosses the line x equal to a. So put x equal to a over here. A square is equal to ay, so y will be equal to a. So where the parabola crosses the line, it crosses at the point a comma a. So this is the point a comma a. So now your parabola is ready for drawing. So we draw it in the same red color to denote that it is going to be a part of your boundary. So we have the parabola touch here and to cross the point a comma a and move like this. Now we are done. We need to fix the region. We see that this region is open, this is open, this is open. And how about this portion? Now this is your axis of reference, which we have made it as black. So if we had made it into the same color, then this would have caused some confusion. So to avoid it, we have made it into black. And so this is going to be now open. This is open and this is open. So what is going to be the closed region is this portion of the triangle, which is going to be available over here. So the required region for integration is going to be this one, along this line and along this parabola. So this is going to be my region of integration. Now coming to the problem, getting back, we are done with the first step, change the limit direction. Second one, we have sketched it, and the third one, now we need to fix the new limits. We are now in the step 3. How to fix the new limit? So given problem is in the direction of y. So given problem is in the direction of y. So the new problem has to be in the direction of x. So I'll have to convert the problem which is in the direction of y by change of order. So when I change the order, it turns out in the direction of x. So what is the direction of x? This is the direction of x. This is the direction of x. And how does the direction of x move? It moves from left to right. It moves from left to right. So which is my shaded portion? This is my shaded portion. Let me move from left to right. When I move over here, I see that I move from a straight line x equal to 0 to the portion of a parabola. And when I start moving in the same direction, I notice that when I come towards the top portion, I move from the straight line x equal to 0 to the straight line x plus y equal to 2a. Hence, we notice that the region while we move is not going to be the same, but it varies from a curve to a line after it crosses a certain point. So in this case, now what happens is we need to split the portion into two parts, I1 and I2, and then integrate it. So we will block this diagram and then make it fresh, new in the next page. So this is going to be my point. So I am going to region of integration. Now this is going to be the point 0, 0. This is the point where we have 0, 2a, 0, 2a. This is the point of intersection a, a. So this is a, a. So when I am going to drop a perpendicular from over here, I notice that this is going to be the point where it cuts. So 0, a. Now the name of this line is going to be x equal to 0. Here also x equal to 0. But when I move along over here, this curve is now called by the name. The name of the curve is going to be x square is equal to ay. And over here you have the straight line to be called as x plus y equal to 2a. So let me name this as region 1 and this as region 2. So I'll have to fix the limits for both my region 1 and region 2. So my total value of I, the evaluation of the integral, is going to be I1 plus I2. Fixing the limits for I1. So how to fix the limits? In the direction of x. In the direction of x. So what we will have to do is draw a line parallel to my x-axis. So draw a line parallel to x-axis. Start from left, move to your right. Left to right. So what will be the lower limit? The lower limit, the left hand limit, is x equal to 0. What is the upper limit? X square is equal to ay, x is equal to square root of ay. So this gives me square root of ay. Now moving to the limit of y. From here to here is my first region. The limit of y is 0 at the bottom and the limit of y is a at the top. So y varies between 0 to a. So now coming to the limit for the integration number 2. So for my integration number 2, let me draw a line again parallel to my x-axis, starting from left, moving to the right. So what happens over here? I notice that the limit is going to be integral x varying from the lower limit is taken as 0 and the upper limit is x plus y equal to 2a. So what will be x? X is equal to 2a minus y. So this becomes 2a minus y. And how about the limits of y? The limits of y for my second portion is from here to here. So when I move from here to here, the starting point of my y is a and the ending point is going to be 2a. So y varies between a to 2a. So now we are ready for integration. Our limit have been got for our step 3. So the function to be evaluated is going to be xy. X comes first. So dx dy followed by here the same function xy followed by dx first and then dy. So now let us start integrating. With respect to x, y is a constant, x square by 2 between the limits 0 to root ay. So this gives you y by 2, root ay on integration is ay. So it is a y square on integration is y cube by 3 between the limits 0 to a. Now when I am going to integrate it 0 to a with respect to dy, I have the final answer as a cube by 3. So the value for the limit will be over here it is going to be 2 already. So it is going to be 2 into 3. So it is a to the power of 4 by 6. So this is my answer for my first integrand. Now coming to the second integrand, I will have to integrate it keeping your y as constant, x square divided by 2 between the limit 0 to 2a minus y. Y by 2 is kept as such. You will have to integrate between a to 2a. So this gives you 2a minus y the whole square, which I will have to integrate between a to 2a with respect to your y next. So y expanded using a minus b the whole square formula. So you have 4a square plus y square minus 4ay. So divided by 1 by 2 is outside. Integrated between a to 2a. Now expansion of this, so will give you 1 by 2 integral. So it is 4a square y plus y cube minus 4ay square. This has to be integrated between a to 2a with respect to dy. Now this gives you 4a square y on integration y square by 2, y power 4 by 4 minus 4a y cube by 3. So apply the limit between a to 2a, and this is going to be half, which is going to be 2 times of 1 by 2, 2a square. So this is going to be 2a the whole square. 2a the whole square makes it as 4a square minus a square plus 1 by 4 times of, this is going to be 2a whole power 4, 16a power 4 minus a power 4 plus, minus 4a by 3. 2a the whole cube is 8a cube minus a cube. So when you simplify this, this gives you the answer as 1 by 2 times the quantity is going to be 2a square, 3a square plus 1 by 4, 15a power 4 minus 4a by 3, and this is 7a cube. So on simplification, this gives you the value 5a power 4 by 24. Now the total value of I is I1 plus I2. So this is got as I1, which is a power 4 divided by 6 plus 5 a power 4 by 24. So this gives the total value as 3 a power 4 by 8.